This conference will now be recorded.
Good afternoon, everyone, and thank you for joining the latest SCLF webinar. This is number 9 in the series. Delighted today to welcome Patrick Flood of Juta to do the presentation. We'll introduce properly in a wee minute. But just first of all, before we get started, just hope everyone is feeling safe and well. And just do a wee bit of housekeeping. So when everyone's joined the call today, you will have joined muted. If you could just remain muted for the duration of the presentation. But there will be opportunities if you want to have discussion or have a chat at the end of Patrick's presentation. Just to let you know that this recording today is being, webinar today is being recorded, just so that if anyone isn't able to make it, they can play it back, or if you want to watch it again. What I propose probably is that we maybe not record the discussion at the end, so we'll just record the presentation and the discussion can be offline. Just a wee note about next week. So we have another webinar next Thursday, same time, and it's going to be a bit of an update from, or sort of like a follow-on from John Cleland, who did the 101 sampling protocols a couple of weeks back. So there was some feedback on some of the surveys looking for some more sort of in-depth look at sampling strategies, sort of like numbers of samples and you know how many for each type of scenario. So John's kindly agreed to do a second go at that. So he's going to be doing that next Thursday. So I'll be putting the invitation out for that probably later on today or tomorrow. So without further ado, I will get on to introducing Patrick. Now, as with all our speakers, we provide them the opportunity to nominate a charity, and you will see in the chat box at the right-hand side, which you can use throughout to either chat to other participants or to put in questions. You'll see in there that I've put in a link to Patrick's nominated charity, which is Pendleside Hospice. So if you are able to make any sort of donation to that, that would be much appreciated. So Patrick is a technical director at Juta UK and is a geologist with over 50 years research, design and practical experience in geotechnical engineering. And that's been in relation to many fields of civil engineering construction, including investigation, design and construction of a wide variety of projects incorporating geosynthetic solutions. And he's going to be speaking to us today on sort of sustainable sort of gas protection measures. So without further ado, I'll just hand over to you, Patrick.
Good afternoon. Thank you, Alison. Can you hear me okay? Is the microphone working as intended? Yeah, oh, that's a thumbs up. Right, I'm going to collapse you there. Yeah, so good afternoon. Grab yourself a coffee. Pants are optional, and if there's a fire, you're on your own. Sit back, hopefully enjoy my dulcet tones, and let's try and learn a little bit more about ground gas barriers, particularly the sustainable and appropriate selection of these materials. So let's see if we can get this clicking forward. There we go. So I'll just give you a brief overview of who Juta are. It still surprises me today. I'm 4 years at Juta now, just how few people have actually heard of Juta. Then we'll touch on gas membranes, sustainability, appropriate specification, current guidance, considerations when specifying or using these materials, and we'll end with dispelling some myths, a little Q&A. The idea of today is obviously to highlight conflicts, both in terms of marketing materials and current understanding and learning, and increase your awareness of material limitations. And what I always say with these presentations is, if you haven't gone away from here and learned anything, then I've failed in the intention of what this CPD is, so please feed that back. If anybody has any questions, I stuck my email address at the front there. You can always send me an email, we can chat in more detail if required. So Juta, As a group, we're a Czech manufacturer, so 330 million euro turnover, 2,200 employees. We have 14 factories, 13 of which are in the Czech Republic, one is in the UK. We supply geosynthetic materials all over the world, multiple technologies, which I'll touch on next slide. Our UK operations, we have 3 different business units. So as a footprint, we're about 50 million pounds in turnover. We have U2UK, which focuses on the ground and down, so everything that's buried in the ground. We have a company called Easy Trim, which does roofs and walls, so breather membranes. And then we have a company called Ecovin. Now, Ecovin is a recycler and producer of recycled raw material and extrudes PVC plastics for use in external building facades. As a group, we manufacture geomembranes, geotextiles, geosynthetic clear liners, so GCLs, bentonite systems, geocomposites, so in terms of what we're going to talk about today, venting composites, synthetic grass, geogrids and erosion control matting. So again, I'm going to move quite quickly through this stuff. If anyone wants to know more about our business in general, just let us know. In the UK, we use this Titan logo, this Spartan helmet. I'm not a marketing person, but our marketing people are very proud of themselves with what they've come up with here. And it's supposed to represent this titans of industry thing. So we try and lead by example, if you like. As you would expect from any large manufacturer, we invest heavily in continuous development. So we have 42 individual BBA and NSAI certifications across our product portfolio. And we're actually at the minute BBA's biggest customer. I'm sure they're enjoying us at this moment in time. Very much involved in driving standards, so I sit on various British standards committees, international standards committees across a whole range of materials, so not just ground gas membranes, but geosynthetics in general. And we're heavily involved in the UK with IGS, which is the International Geosynthetic Society, in terms of promoting education and awareness of these sort of materials. We're very, very much customer focused, so we'll touch on it as we go. But our objective here at UTA is to provide the best solution always, yeah. If that's the most value engineered solution, then that's just a consequence of us doing things right. And solution sales rather than asset focused. So when we come to ground gas, we have a tendency in industry to ignore it as long as possible. I mean, I look at the list of names present today and the sort of audience I'm talking to. I would hope most people who are listening today are not ignoring things like ground gas and ground contamination, but it is generally ignored by industry. If we weren't ignoring it, there'd probably be less chance for people like myself to do these sort of presentations and talk to you guys. But we're generally looking at, in the UK and Ireland, radon, methane, carbon dioxide, and then VOCs. So VOCs, more prevalent at the minute, particularly with regards to brownfield developments, all those nasty chemicals left in the ground from our rich industrial heritage. So where before environmental permitting regulations came in around discharge, we just used to tip it in the ground. So it just sits there waiting for us to deal with it at some point in the future. I usually sort of ask people at this point in time, how many people have heard of any deaths associated with methane and carbon dioxide? We don't hear about a lot of people either asphyxiating or houses just randomly exploding. Yes, there are cases of these sort of explosions, but they are fairly limited. There are far more deaths associated with radon. So obviously radon related lung cancers, primarily 1,100 people last year attributed to radon cancer. But yet we perceive radon as lower risk, which is a slight oddity in industry. We'll just touch on the HAKI report. Again, if any of you are struggling to sleep, it's a very decent sleep inducer here, very detailed document. Obviously, HAKI commissioned a report by industry with regards to Grenfell. This is not about Grenfell, but the wider implications were that there was an identification that industry as a whole has an issue in terms of a race to the bottom attitude. So we're constantly trying to cut corners and costs, either through the ignorance, indifference, or because it's bad sales, so the system does not facilitate good practice. And we've been tasked as an industry to embrace change improve on existing practices, and innovate to achieve these long-term sustainable aims and objectives. How we interpret sustainability and long-term quality as a manufacturer essentially comes down to three distinct points. So, is the material we're supplying suitable for the intended application function? So, does it do what we say it does on the tin? Is it fit for purpose? Can we install it? So if we've got to, with regards to gas barriers, install these materials across the footprint of the building, is that possible? So things like flexibility always come into play, and then design to last. So this durability aspect, that is a quite sustainable approach. If we manufacture things to last a long time, as opposed to just single use or short-term use, that's a sustainable approach, and it's more an engineered response. So we generally find that end users or clients have a different understanding of what sustainability means with regards to manufacturing. So you generally get this concept of we're going to be incorporating recycled or reused material. So end users think that's environmentally friendly. Your manufacturers look at it and think we have limited design service life on these products because we cannot guarantee repeat source quality of the raw material, which means we can't warrant the performance over time. So there are durability issues that can potentially compromise critical application functions when manufacturing with recycled raw material. And what that does is it creates two classifications of products. So we have what are called LLGs, so limited lifetime geosynthetics. These are products which are not designed to perform a critical function for a long time. So usually the application function is restricted to 5 years, sometimes up to 25 years. So you may be looking at slip membranes or some facade landscaping details on the external side of a building rather than anything that goes on the inside. Extended lifetime geosynthetics, or ELGs, are generally providing critical functions, so such as protective barriers like gas membranes, and they are designed to last for a period or have an anticipated design service life of at least 50 years, which is Eurocode 0 Cat 4 structure, residential housing. So your Cat 5 structures, for any structural engineers who might be in here, for the highways, rail buildings, which are Cat 5 structures, have a 100-year anticipated design service life. So you're looking at much more robust and additionally tested materials. Gas membranes, one of the most common questions we get asked probably 3-4 times a day is your gas membrane also a damp-proof membrane? So all gas membranes are damp-proof membranes. They start life as a damp-proof membrane. They're harmonised and certified under European and British standards as damp-proof membranes, and then we do additional things to them to give them gas resistance. Okay, so we have harmonised European standards, and then we have local standards, which are country standards, so British standards, American, we might have some Australasian standards. Gas resistance is a local standard, so that varies by country in terms of what their relevant guidance documents state is appropriate for gas resistance. So in terms of European standards, all materials sold into the EU, we will still be bound by CE marking, unfortunately, or fortunately, if you look at it that way, when we leave the European Union or the Common Agricultural Market. But it must be accompanied by a CE mark, which details the application standard. So the product has been certified for use in the application standard to the relevant harmonised European standard, and it's marked as such, which is all about traceability as well. Yeah. The overriding standard for gas membranes, which is the DPM standard, is EN 13967, flexible sheets for waterproofing, and that's a harmonised European standard. So all gas membranes that enter the UK market should be accompanied with a CE mark for EN 13967 for damp proofing. Okay. It sets testing criteria and what we are obliged to provide as a manufacturer in terms of minimum stated properties. Or essential characteristics. So we have to declare these. That's a legal obligation for us to conform to CE marking, that we declare these properties. Now, you would be probably amazed, maybe not, how much material enters the UK market and is used in these critical application functions without CE marking. Yeah, so as a basic check, we should be looking at CE marking for traceability. EN 13967 actually has two notations, so you'll see EN 13967 type A and type T, or A/T, which is both. So A is above ground, so it has a 2 kilopascal, which is a 200 millimeter hydrostatic head test pressure, and T for tanking or below ground is a 60 kPa hydrostatic pressure or 6 meter head. So A for damp proofing, T for waterproofing. If it's EN 13967 A/T, it means it can do damp and water. So the majority of above ground gas membranes are EN 13967 type A, and that restricts their application depth to within 200 mil of below ground level. Yeah? Now that relates to what warranty provision your manufacturer will give you, which I'll touch on later. So where we start using these gas membranes, or what is traditionally a gas membrane, underneath a lift pit, which is 2 meters below ground, we can't warrant the application because the material is not tested or certified to perform the application function in those conditions, yeah, for a period of time which exceeds 50 years. So essential characteristics, and again, if we look at what we should be seeing on a classic technical data sheet, my marketing and sales department go mental because I just want to put data on everything. Yeah, because I'm an engineer, so I just want to see the data. Like, I don't want to see all this fluffy language around how great the product is, how we're market leaders, and how many millions of square meters we've sold. I want to see the data. So as a minimum, we should be seeing reaction to fire, tensile strengths, impact resistance, tear strengths, and a bit of durability information for EN 13967. So these are the required properties or the essential characteristics we are mandated, legally obliged to declare for providing material onto the market as a proprietary gas resistant damp proof membrane. So again, don't do it right now because you've no pants on, but when you get a chance, rush off, check your folders for the data sheets you've got in there, and just sense check how many suppliers or manufacturers are providing you with that basic level of information. Local standards define the regional requirements. So primarily we're looking at British standards, and the UK has some of the world's best local standards. So the UK is world renowned for providing good, robust standards in terms of local requirements, yeah, but they're not mandated, so that it's not a legal requirement. But primarily we're looking at BS 8102 waterproofing requirements, BRE 211, 414 radon, contam land, 8485 methane carbon dioxide, C748 for VOCs, which again is picking up more and more traction these days because of the brownfield side of things, and C665, which is slightly out of date. I have a minor issue we can discuss later if you want, around the NHBC Amber 1 /CS2 classification. That's a misnomer, but it stems from 665 and that traffic light system. But these are local standards or regional requirements. They're not legal, so we are not legally obliged to comply to those standards. So it's guidance. Yeah, this is the information we'd expect to see in the UK if you are purporting your materials to be a gas membrane or a waterproofing membrane. These are the relevant standards you should consider. Yeah, European standards form a legal requirement for manufacturers. So common, excuse me, common gas barrier types. We have monolithic polyolefin, so this is the same composition of material throughout. So your HDPE, LLDPE, LDPEs, PPs, polypropylene, sometimes recycled. So this is very old technology. Reinforced polythene. So this is the scrim reinforced materials which give improved resistance to tearing. So the flat sheet plastics have had a tendency to sort of tear. So wind, you would get wind uplift, then you would see these huge lateral tears across the material around the folds. Then we've got, which is a very common breed of gas membrane at the minute, the aluminium foil reinforced polythenes. This was primarily driven by the change to BS 8485 in 2015, where we dropped in the gas transmission rate as a benchmark for manufacturers. So we all raced to test our materials, and we found that we were looking at aluminium as the most reasonable course of action in the short term. And then we have this new breed of materials, which are the multi-layer polyolefins. So these are 5 or 7 layer products, usually with an EVOH barrier in the middle and then protected by various layers of polyolefin on the outside with no aluminium in them. But all of these materials have various limitations, and what we don't do as suppliers or manufacturers is shout and scream about the limitations. I mean, why would you? UTA is the biggest supplier of Aluminium Foil gas membranes into the UK, and 50% of the jobs we're supplied onto, we probably shouldn't be using it there because of the limitations, but we're not the regulator. So if the clients, end users, engineers, architects don't want to listen to us, then that's on them. The end use of the produced part or the product should always determine the choice of raw material. So if we look at the history or the development of gas membranes over the years, 70 years ago, most of the materials supplied to perform the application function were flat sheet HDLLs, PP membranes, used commonly across the world as moisture, vapor and gas barriers. And we've developed our understanding over time, so both in terms of material performance limitations in the built environment and the advancements in technology and processing. About mid-90s, so sometime around 95, 96, all of the geopolymer producers, manufacturers in the world realized we could start reprocessing some element of finished goods, potentially adding in an element of recycled product from single-use plastics, and produce materials with limited lifetime application functions. Now, around the same time, so early 2000s, industry stopped asking about durability. Now, I sort of remember this because I started working in consultancy in 2001, and the first thing I asked was, well, how long is that material going to last? Like, if we stick a plastic membrane around that building, it's going to get trashed. It's going to get absolutely trashed. Oh, no, we don't talk about that, Paddy. We don't talk about that. So we just stopped asking about durability. Like, you know, how's it going to survive the build process? How's it going to survive the post-build process, so backfill, concrete install, and then how long will it perform that function? Because at design stage, we've assumed, let's say the gas transmission rate was X. Yeah, will it be X for 50 years, right? And this is a consideration in all designs. So for recycled products, that is absolutely not the case. So we cannot warrant that function over time. It's a very cost-effective or cheap way of producing barrier materials, because the raw material, which is mostly single-use plastics or plastic bags or stuff in the ocean that's killing whales and turtles, gets sent to us in big containers. We reject it. We don't use anything recycled, but others do for these limited lifetime materials. But we've seen a prevalence at the moment to buy into this. It's green, it's sustainable, we're using recycled material, and we're producing radon membranes or low permeability gas barriers. I mean, low perm again is a bit of a misnomer. Give it a value. And it's creeping in, and we see the use of more and more of these type of materials in the built environment, which are wholly unsuitable. We've actually, over the years, started to produce much better barriers out of virgin raw materials, so we can use less polymer, we can use it more energy efficiently, and we can make sure it lasts for a long time. So it's the two different sides of sustainability and what it means in regards to the end use of the product. Yeah, hopefully a lot of this is common sense, but I tend to find maybe not sometimes. So if we look at the design guidance and what we should be considering, we've got, as some would have you believe, like the gospel. The gospel according to BSI, BS 8485, updated in January 2019. So it is the most up-to-date and relevance guidance document out there. Here's my colleague arriving 25 minutes late, noted, black mark. So you're all familiar. We've got a classification system. It's a risk matrix, and we're going to this point scoring system. Obviously, the CS can be defined by simplified analysis using GSVs or a more quantitative determination of the actual risk. We're focusing on obviously the membrane side of things today. We're happy to look at the document as a whole if anyone wants us to do any CPD on BS 8485 in more detail. And you've got a lot of text here, and as an engineer it really upsets me because there's an overuse of the word sufficiently. So we say sufficiently impervious to ground gas, and then we define a benchmark value, which is great, and that was actually a really good thing for industry to have this. What is sufficiently impervious to ground gas without any further assessment? It's less than 40 millilitres per metre square per day to ISO 15105 Part 1 manometric. Material should also be sufficiently durable, so durability is a consideration in there for the anticipated design service life. Sufficiently strong to survive installation and follow-on trades, sealed to the entire footprint, and then verified, so quality controlled. You know, you'll have heard probably other people say it. It doesn't matter how good the material is, if it's installed like a bag of spanners, then it isn't going to work. So the quality of the install and the checking, particularly of the sealing around penetrations, corner detailing, to ensure you've got a robust sealed system across the footprint of the building, is an important process. But sufficiently, yeah, we can define it. So when it comes to sufficiently durable, we've got manufacturers' material warranties. So as I touched on earlier, if you are installing, for example, a GP1 product below a lift pit, and then you come and ask UTA to give you a warranty for the material for building control, and they're expecting to see a warranty of 50 years for the material, then you ain't getting it from UTA. We're ethical in our approach. We'll tell you shouldn't be doing that. Others may give you that. I don't really know, to be fair, if anyone is doing that. I doubt it. I just don't think we're asking for it. But if we look at, clicking not coming through there. If we look at puncture resistance versus pressure, there we go. Most gas membranes sit in this 1 kilonewton puncture resistance mark, or 1,000 newtons, which is primarily why your manufacturers or designers will look to incorporate the use of a sand blinding layer. So the lines across the detail are various stone grading. So blue line 2 mil, orange line 5 mil, 20 mil, 40 mil stone. Pressure applied, and then puncture resistance on the y-axis. And you've got puncture resistance of the membrane plotted there. 600 kPa applied pressure is standard protection efficiency testing for geotextiles. So we know a geotextile will generally protect a membrane under a 20 mil aggregate or laid down onto a 20 mil aggregate before the membrane goes on there, and 900 kPa for truck loading. So you know, we generally don't encourage the use of vehicular movements on these membranes, and particularly no slewing. 8485. Great guidance document, encourages use of qualified installers. Again, as we creep through the coronavirus period as well, it becomes more prevalent. So ground workers are looking to save money by not using specialist installers. So they say, oh, we can do this ourselves. You know, we'll get someone to verify it, validate it, we'll tape it all together, and it'll be fine. Someone's going to sign it off for 500 quid, I'm happy. But the reality is they generally aren't doing that every day. They don't hold the relevant insurances to give workmanship guarantees, which is why the specialist installers exist. So they are there in terms of specialists and experienced qualified professionals in that field, and they have insurance, so they can give guarantees on the workmanship. Validation is a requirement in there, and as is the consideration of additional influences on the system, such as hydrostatic pressure. They throw it in there sort of quite subtly in BS 8485 about hydrostatic conditions, without making much reference to the fact that most gas barrier materials are actually not designed to be in those conditions. It'd be, for me, far more reasonable to just say we should be using more robust materials in below ground applications. Just while we're on BS 8485, I'm just going to quickly touch on Table 5 as well, which is the structural element. There was a change in 2019 to effectively remove the grading reference for anyone who's involved in structural waterproofing. You had a whole host of confusion around point scoring for graded environments. So the point score in Table 5 is for the structure only, just the concrete element. It's not to be attributed to things like internal cavity drainage membranes, which are inherently allowing the risk on the inside, which is bad practice, or for the membrane on the outside. Now, the note at the bottom there says if a membrane is used around the structure to provide type A waterproofing, it can be assigned a gas protection score if it conforms to Table 7. So it must meet all the requirements of Table 7. So again, you'll hear quite a few people say, oh, such and such has written me a report to say my membrane is gas resistance. That's complete crap. It should be a risk assessment based on any particular given site, not a holistic approach. An 8102, which leads us nicely into here, again for anyone dealing with below ground structures or structural waterproofing. Because of the 8485 less than 40 mil benchmark, we've seen an advent of the use of aluminium foil products below ground. So what some suppliers are doing is they'll take an aluminium foil, gas barrier, damp-proof membrane. They'll take a GCL, which is an old school waterproofing product. They'll glue the two together and they'll say we've got a gas and waterproofing product. So we've got a gas barrier, got a waterproofing barrier, stick the two together, we've got a gas and waterproofing barrier. Again, that's a recipe for disaster. So aluminium foils, as we've talked about, they're not designed or warranted for these application functions. On the negative side, they remove the bonding element of these 8102 type A bonded systems. And on the positive side, it prevents hydration of a GCL type layer. And contrary to popular belief, aluminiums don't self-heal. So these products are marketed as self-healing gas and waterproofing membranes, but they contain aluminium. So the last time I checked, Skynet was not live. So Terminator 2 technology, it doesn't exist. So, you know, if it does, we probably shouldn't be here. We should be running for the hills, getting in the bunkers. You know, metal does not self-heal, like fact. So that's a red flag in terms of marketing. C748, guidance on the use of plastic membranes as VOC barriers, is a risk-based approach. So again, there's some confusion of this document because unlike 8485, there are no quantifiable performance limits of material like the gas transmission rate of less than 40 mil. It's an information gathering exercise. So what this document does is it points you in the direction of what information you would expect to see where specifying or considering materials as VOC barriers. And the uncertainty at present is there are hundreds of products out there which say they are VOC and hydrocarbon barriers, without this information. Hydrostatic application conditions are a consideration in 748. So obviously the assessment with gas in solution or hydrocarbon solution is different to gas or VOC vapors. But without the information, you can't even begin to make those assessments. So C748, again, as I'm sure many of you will know, has a minimum set of test criteria you'd expect to be provided by the manufacturer / supplier. In that it should be tested to the permeation rate for the challenge chemicals, so the big 9, so your BTEX, hexane, vinyl chloride, PC, TC and naphthalene, to ISO 15105 part 2, and then have durability immersion testing against all those to EN 14414 and 14415. Now, the only one we can't do is vinyl chloride, because an immersion test for 60 days at 23 degrees C with vinyl chloride is creating a bomb. So no commercial laboratory will complete that test. It's a military grade test and it's £250,000 for the test. So it's not commercially viable. So anyone reporting that is basically bullshitting you. So just be careful on that as well. An example here of an aluminium foil which has come out of an immersion test or an immersion bath. This is actually an alu foil coming out of an acid bath, and you can see the acid has actually stripped the polymer back and begun to attack the aluminium. So it's corroded around the scrim nodes of the aluminium foil. And again, this forms the basis of why we don't warrant the use of these materials in the application function, because we know they will fail. over time. Yeah, it's a limitation of the material. Validation to C735, good practice, is a check, design and detailing service. They will check the competency of the installer, and they'll integrity test the membrane, and then they'll sign off. Now, again, it's a point of debate for me with a lot of the verification or validation companies in terms of the liability. Like, we have no liability here. Well, I'm afraid you do, particularly where the installer is not holding relevant insurances for workmanship guarantees. So there's a big portion of liability if you are checking and signing off work for unqualified and uninsured installers. And MVQ level 2 doesn't provide a level of workmanship insurance. That's for the individual. Yeah. It's often overlooked, again, as I would imagine there's many people in this room who would agree with that. You'll be brought in at the last minute, like, oh God, we need to get this membrane signed off. Like, we've half covered in concrete. Yeah, what can you do? Well, you can't do anything. It's problematic because it's completely unregulated. Now, there is some self-regulation going on. So there's the British Verification Council, the BBC, which has recently formed, and the Property Care Association is kind of picking up the baton on that side of things. And then you've also got Claire, who is running this accreditation scheme for verifiers, which will be, as I understand it, like a license system. So you will go through a competency check and become a licensed verifier. So industry is self-regulating because they realise it's full of cowboys. If I got bored at Utah and I decided I wanted to make some quick bucks, I would set up a verification company and start validating gas membranes. And then the insurances around the whole thing. Again, if you are sat in a geo-environmental practice, then it is natural for you to have insurances for that type of work. It is not for some pop-up overnight verification and validation companies. So just be aware of that. So considerations, guidance creates a shopping list for information. And again, it's like, almost like you're speaking common sense sometimes, like, oh, of course it does. But we don't always go down that list. You know, we start to become comfortable with what we've done in the past. But users are encouraged to seek this information every time and take into consideration the application setting to determine whether the proposed barrier is suitable, fit for purpose, and designed to last. So, what is the anticipated design service life of a gas-resistant DPM? Put your answers in chat. I'm not gonna wait, but let's see who's been listening or who's still listening. So maybe no one. Alison's going to tell me everyone's gone to sleep or left. That's fine. It's just me and her. So moving on, bear that in mind. What is the anticipated design service life? So we should be looking for CE marks. CE marks, DOPs. DOP is a declaration of performance. So this is a manufacturing quality control of the material, and that is what sets the benchmark for a warranty. So we will give you a material warranty that the gas barrier will still be at within 95% confidence limit after a period of 50 years against that DOP. And that is essentially what a warranty is. It's a time frame for which we expect the material to perform at those values. Radon membranes, we should be looking for permeation rates. Again, I see a lot of material out there without permeation rates, diffusion coefficient, better word, without the diffusion coefficient. Methane and carbon dioxide permeation rates for materials as well. There's a lot of carbon dioxide risk assessments or risk appropriate barriers selected without the permeation rates for carbon dioxide. So they'll say, well, BS 8485 says we need to test the methane transmission rate to 15105 part 1. But methane is not the risk driver on this particular site, it's actually carbon dioxide. So without the information, how do you know that that product is performing the function as a carbon dioxide barrier? Common sense. VOC permeation rates, so we should be looking for the information, asking the question, challenging the supplier. The durability data, particularly with regards to immersion in challenge chemicals, and then certification, so independent certification, BBAs, NSAIs, BDAs sometimes, and the material warranty. So we will give material warranties at the end of a project. So once the material is installed, that's when your warranty from the manufacturer comes. It doesn't come up front as part of the sales pitch. Yeah, you can get a draft warranty, so I can show you what our warranty looks like, but I can't issue you a 10-year warranty for material until it's been installed, signed off, and validated. And without the information, how are we going to hammer it home? How do you satisfy yourself the product is suitable for the intended application function, fit for purpose, and designed to last? Yeah. Marketing literature is not sufficient to make an informed decision. Myths. Weight and thickness, yeah, absolutely meaningless to a manufacturer. So they're non-harmonized properties, so we don't have to declare them. There's no legal obligation for us to declare weight and thickness because they are not an indicator of application performance or mechanical and hydraulic performance. They're a good index check for manufacturers, yeah, so we know the way we manufacture a type of product with X amount of density of polymer will give a puncture resistance of Y. Yeah, so as long as we're in that weight limit in terms of manufacturing, we're looking to get mechanical performance at the end of it, CBR, tensile strength, whatever of Y. Yeah, so we're just going to run through a quick example. I'll just see if I can run out the chat while we go. So get ready. So quickest 10 answers win a prize at the end of this round. So quick fire. So we've got a site, yeah. There's an issue with radon. We're looking at radon resistant DPMs. We've got 2 products. So your options are 1 or 2. Yeah, that's it, 1 or 2. So quickest 10 answers win a prize. 2 products are put in front of us. They're both marketed very well. We've got product 1 with a weight of 440, product 2 400. Roughly the same thickness. One is slightly longer than the other, one is slightly wider. They have a puncture resistance. Product 1 is 3 kilonewton, product 2 is 2 kilonewton. Which is the better product? Quick fire, fastest 10. You're all slow. Oh, well done, Rebecca. You won a prize. 1. Okay, so it's interesting. that's good. You don't have the relevant information to make the decision. Because it's a radon membrane and there is no information on radon diffusion coefficients on the information provided. So you turn around and you say, listen, you told me this is a radon membrane. Where's your radon diffusion coefficients? What's the material made of? Manufacturers come back and say, product 1, it's recycled polyethylene, it's like super sustainable, it's a folded sheet, comes, we get shitloads on a pallet, it has a radon diffusion coefficient of 1 × 10⁻⁸. Product 2 is virgin, it's single wound material, has a diffusion coefficient 1 × 10⁻11. Which is a better product? Type away. Okay, good. So we're swinging. We still don't have enough information though, because we know the anticipated design service life of the radon membrane is at least 50 years. So we go back and say, thank you very much, but how long? Hey, well done, Catherine. What's the anticipated design service life? So product 1 comes back as 10 years. We're prepared to warrant the material for 10 years. Product 2 comes back as 60 years. If anyone thinks it's product 1 still, then you need to quit your job and go verifying gas membranes. 2 is a better product, and the fastest 10 have just won the ability to specify UTRA on your next project. So well done, guys. Congratulations. And to tape or not to tape, that is the question. So we again, we get often asked this. So adhesives, so butyl bitumen-based products, are not designed to last indefinitely. So that's a chemical reaction. That TAC is a chemical reaction, yeah? And as we know, everything in nature wants to get back to equilibrium. So we're looking for stable inert materials. Butyl bitumen-based products are not. So you are looking at, in favourable scenarios, a typical lifetime guarantee from a tape manufacturer about 10 years, yeah? So VOCs and hydrocarbons will readily attack and degrade these adhesive type products. So C748 says that where tapes are demonstrated to have the same performance as the membrane, they can be used. Yeah, good luck with that because they don't exist. Yeah, I've spent the last 4 years of my life scouring the planet for these type of products. They don't exist. Yeah, we should be thermally jointing these materials in these aggressive environments because the joints are the weak point. The joins, the seals to penetrations, corners are the weak points, and we are using the weakest performing product in the most critical parts of the install. Okay, frozen again. So this particular site, I'm going to pick on this, is using a marketed VOC barrier without any information to C748. So it's marketed and sold as a VOC barrier without any permeation rates for the challenge chemicals, challenge 9 to ISO 15105 part 2. And it is sealed around the corners and the penetrations into the slab with an aluminium foil bituminous membrane. So the anticipated design service life of that system drops to 10 years. So that what that means is it's reasonable to expect a level of maintenance will be required on that system after a period of about 10 years, or the manufacturer won't warrant that system, or supplier. So this is installed or provided by a supplier who is effectively just looking to sell material. So again, if I sell a pallet of tapes with every job, sales are jumping up and down because we've increased the value of the sale. If I say should use a specialist installer, thermally joint as much as possible, like I reduce the value of the sale. So selling tapes and accessory products is a sales and marketing approach. Yeah, it's not a competent technical and justified argument. So tape joints are acceptable for low risk, and I've highlighted low, in waterproofing and radon protection. So this is market perception. So market perceives that tape joints are acceptable for these application scenarios. For me, which is a bit of a misnomer, because as we identified earlier, more people unfortunately die of radon-related cancers than do of methane and carbon dioxide and exploding houses. So the risk of your basement flooding with water, your stud in 2 foot of water is reasonably high risk. So we should be looking to seal these materials as best as possible. Welded joints are recommended for ground gas protection. Yeah, they have enhanced durability. That is true. So for me, we should be using thermal jointing in all occasions, and welded joints are required. Hydrocarbon VOC is, again, that's true. So we cannot demonstrate a taped system as a VOC protection performs as good as a jointed, thermally jointed system. If in doubt, ask the question about anticipated design service life, yeah? And if someone takes the punt of lying to you, then you have it in writing, yeah? So if something does go wrong, you have it there in writing. Well, such and such said, it's going to last 60 years with this tape without any information. Take a punt on me, please. It's on them. And we just have to go back to basics. For me, it's just about applying common sense. So we learning from our mistakes, improving our knowledge and understanding over time. And the copy and paste mentality of, we've always done it like this, like we've never had a problem before, that actually stifles innovation. So we've got to continuously learn, try new things and develop with the industry. Again, I was speaking to a guy the other day, and he was saying he'd had the same CPD from a particular supplier twice a year for the last 5 years. What's the point? What's the point? You're not learning anything new, having the same crap thrown at you time after time after time. Yeah, we've got to change, like try new things, listen to new things. Yeah, and then these third-party certifications, they provide reassurance, but that's all. They're not a warranty provision. There's no liability from something like a BBA certificate, which upsets me because we spend an inordinate amount of money with these guys to use the branding and have the certification, but all the risk and liability and warranties are sat still with UTA. Thank you very much for your attention. For anyone who's still awake, and obviously we're happy to discuss anything you want on the back of that.
That was brilliant. Thank you very much, Patrick. And my apologies for completely getting the pronunciation of Utah wrong at the beginning of this.
Don't worry, we've been called worse. Don't worry about it.
I think what I'll do is I'll just stop the record just now, and we can just do some questions, and it allows people then to be able to interact if they want to. So